my dear student and friends. Today I am going to solve some MCQ questions on Jacobian. In previous video, I have explained about the Jacobian and some properties on Jacobian. For reference, you can see my previous video on my YouTube channel. So let's start some questions on Jacobian. So first question is, if u of x comma y and v of x comma y are continuous and differentiable functions of x and y, then Jacobian of uv with respect to x and y is. The four options are given here. Now when we want to find out the Jacobian of uv with respect to x and y, you have to first find out the partial derivative of u with respect to x and y respectively and write it is in first row. Second, find out the partial derivative of v with respect to x and y and write it is in second row. Now you can see here in the first option we have partial derivative of u with respect to x, partial derivative of u with respect to y, and in second row we have partial derivative of v with respect to x, partial derivative of v with respect to y. So option A is correct. Now come to the second question. If u and v are functions of x and y, j equal to del of u comma v by del of x comma y and j dash is equal to del of x comma y by del of u comma v, then j into j dash is equal to. Now j is a Jacobian of uv with respect to x and y, j dash is a Jacobian of xy with respect to uv, then there is product j into j dash is always 1. So option B is correct. So option B is correct. Now come to the next question, question number 3. If x equal to u minus uv, y equal to uv, then del of x comma y by del of u comma v is. The options are 1, 0, minus u and u. So first try to find out the Jacobian of x, y with respect to uv. So first write down the formula of this Jacobian and then find out the partial derivative of x with respect to uv, x with y with respect to uv. So del of x comma y by del of uv is equal to determinant del x by del u, del x by del v, del y by del u, del y by del v. Now find out partial derivative of x with respect to u. X is here, differentiate partially with respect to u, so you will get 1 minus v partial derivative of x with respect to v. Partial derivative of x with respect to v is minus u. Then in second row, take the partial derivative of y with respect to u. Y is here, differentiate y partially with respect to u, so you will get the v only. Then partial derivative of y with respect to v. So y is here, take the partial derivative of y with respect to v, so obviously it is u. Now find out the determinant of this. So this is equal to u into 1 minus v minus v into minus of u. So this is equal to, multiply u to this bracket, so you will get u minus uv. This minus of minus become plus, u into v is uv. This minus uv plus uv get cancelled, so only remain u. So option D is correct. Now come to the next question, question number 4. If x equal to r cos theta, y equal to r sin theta, then the value of del of x comma y by del of r comma theta is. Options are 1 by r, minus 1 by r and minus r. First we'll write the formula for del of x comma y by del of r comma theta. So del of x comma y by del of r comma theta is equal to determinant of del x by del r, then del x by del theta, in second row del y by del r, del y by del theta. Now let's find out the partial derivative of x with respect to r and theta. So x is here, just find out the partial derivative of x with respect to r. So you will get partial derivative of x with respect to r is, the derivative of r is 1, so only remain cos theta. Here partial derivative of x with respect to theta, so derivative of cos theta is minus sin theta, so it will be minus r sin theta. In second row del y by del r is there, so take the partial derivative of y with respect to r, so derivative of r is 1, so only remains sin theta. Now del y by del theta is, take the partial derivative of y with respect to theta, so derivative of sin theta is cos theta, r will remain as it is, so you will get r cos theta. Now find out the determinant of this. So this is equal to cos theta into r cos theta, so it will be r cos square theta minus sin theta into minus of r sin theta, so it will be minus r sin square theta. So this minus minus become plus, so it will be r into cos square theta plus r into sin square theta. So now you can take r outside, in bracket it will be cos square theta plus sin square theta, but cos square theta plus sin square theta is 1, so r into 1 is r only, so option B is correct. Now come to the next question, question number 5. If x equal to AU, y equal to BV, z equal to CW, then Jacobian of x, y, z with respect to u, v, w is, the options are ABC, a square, b square, c square, c is a, b, c, u, v, w, and d is 3abc. So we want to find out the Jacobian of x, y, z with respect to u, v, w. So write down this in formula. So del of x comma y comma z upon del of u, v, w is equal to determinant of, so first find out partial derivative of x with respect to u, v, w, then partial derivative of y with respect to u, v, w, partial derivative of z with respect to u, v, w. So write down here in determinant, so you will get del x by del u, del x by del v, del x by del w. In second row, find out partial derivative of y with respect to u, v, w. So you will get del y by del u, del y by del v, del y by del w. In third row, find the partial derivative of z with respect to u, v, w. So you will get del z by del u, del z by del v, del z by del w. Now find out each and every term here. So del x by del u, so differentiate x partially with respect to u, so you will get only a here. Then differentiate x with respect to v, so x with respect to v is 0 here. Then differentiate x with respect to w, obviously it is 0 again. In the next row, differentiate y with respect to u, so it is 0. Differentiate y with respect to v, so you will get b. Differentiate y with respect to w, so obviously it is 0. In third row, differentiate z with respect to u, so it is 0. Differentiate z with respect to v, 0. Differentiate z with respect to w, it is c only. So now try to find out the determinant of this, so you will get the a, b, c. So option A is correct. Now come to the next question, question number 6. So Jacobian of del of u comma v by del of x comma y for the function u equal to e raised to x sin y, v equal to x plus log of sin y. And the options are 1, second is sin x sin y minus x into y cos x cos y, third is 0, and fourth one is e raised to x upon x. So to find Jacobian of del of u comma v by del of x comma y is equal to, write down the first formula. So it will be del u by del x, del u by del y, del u by del x, del u by del y. In the second row, del v by del x, del v by del y. Now try to find out each and every term here. So del u by del x. So del u by del x means you have to take the partial derivative of u with respect to x. So u is here, differentiate u partially with respect to x. Obviously y is a constant term. So sin y will remain as it is, only take the derivative of e raised to x. So e raised to x is, derivative of e raised to x is e raised to x, sin y is as it is. Now differentiate u with respect to y. So when you are finding the partial derivative of u with respect to y, keep x constant. So you will get e raised to x as it is. The derivative of sin y is cos y. So e raised to x cos y. In the second row, take the partial derivative of v with respect to x. So v is here, take the partial derivative of v with respect to x. So derivative of x is 1 only. Because log of sin y it is constant, the derivative of constant term is 0. Next is partial derivative of v with respect to y. So v with respect to y, x will be constant. So derivative of x is 0 here. Log of sin y. So derivative of log of sin y is 1 upon sin y into cos y. So you will get a 1 upon sin y into cos y. So it will be cot y. Now find out the determinant of this. So you will get e raised to x into sin y into cot y minus 1 into e raised to x cos y. So this is equal to e raised to x into sin y as it is. Cot y is cos y upon sin y minus e raised to x cos y. So this is equal to sin y get cancelled. So only remain e raised to x cos y minus e raised to x cos y. So this will be the 0 here. This will be the 0 here. So you will get third option. Now come to the question number 7. If x is equal to r cos theta, y equal to r sin theta, z equal to z, then del of x comma y comma z by del of r comma theta comma z. The options are theta, r, 0, r square sin theta. So now we want to find out the Jacobian of x, y, z with respect to r, theta, z. So formula I have written here directly. So del of x comma y comma z by del of r comma theta comma z is equal to determinant of del x by del r, del x by del theta, del x by del z, del y by del r, del y by del theta, del y by del z, del z by del r, del z by del theta, del z by del z. Now differentiate x with respect to r, theta, z respectively. So x is here, take the partial derivative of x with respect to r. So derivative of r is 1, so only remain cos theta. partial derivative of x with respect to theta. So derivative of sine theta is minus r sine theta. Derivative of x partial with respect to z is 0. In the second row, partial derivative of y with respect to r. So it is sine theta. Partial derivative of y with respect to theta. So sine theta, derivative of sine theta is cos theta. So r cos theta. Partial derivative of y with respect to z is 0. Then in third row, partial derivative of z with respect to r. So obviously it is 0. Partial derivative of z with respect to theta, it is again 0. Partial derivative of z with respect to z is 1. So just find out the determinant of this. So you will get cos theta into r cos theta into 1 minus 0. Minus of minus, this becomes plus r sine theta in bracket sine theta plus 0. So this will be cos theta into cos theta will be cos square theta r as it is. So r cos square theta plus r sine square theta. So you can take r outside. So you will get r into cos square theta plus sine square theta. So cos square theta plus sine square theta, it becomes 1. So only remain r. So option B is correct. Now come to the next question. Question number 8. If u equal to x square plus y square plus z square, v equal to xy plus yz plus zx, w equal to x plus y plus z, then the value of Jacobian of u v w by x y z. Now find out the Jacobian. So I already written the formula for del of u comma v comma w by del of x y z. So this is the determinant of del u by del x, del u by del y, del u by del z, which is in first row. Del v by del x, del v by del y, del v by del z, which is in second row. Del w by del x, del w by del y, del w by del z, which is in third row. Now try to find out the each and every term here. So del u by del x, partial derivative of u with respect to x, so it will be 2x. Partial derivative of u with respect to y, so it is 2y. Partial derivative of u with respect to z, it is 2z. Now in second row, partial derivative of v with respect to x. So when we are finding the partial derivative of v with respect to x, keep y and z constant. So here y plus z. In del v by del y, partial derivative of v with respect to y. So keep x and z constant. So you'll get x plus z. Partial derivative of v with respect to z. Keep x and y constant. So you will get y plus x. In third row, partial derivative of w with respect to x, it is 1. Partial derivative of w with respect to y, it is again 1. Partial derivative of w with respect to z, it is 1. Now try to find out the determinant of this. So this is equal to 2x into x plus z into 1, that is x plus z, minus y plus x into 1, so it will be y plus x only, minus 2y into y plus z into 1, so it will be y plus z only, minus 1 into y plus x, so y plus x, plus 2z into y plus z into 1 minus x plus z into 1. Now try to simplify this. So you will get 2x as it is in bracket x plus z minus of y plus x. So if I open the bracket, sign will get changed. So this x and x get cancelled. So only remain z minus y. here minus 2y into, if I open the bracket here, so sign will get changed. So y plus z minus y minus x. So y get cancelled. So only remains z minus x. In third term, 2z into y plus z minus x minus z. Now z get cancelled. So only remain y minus x. Now multiply 2x to this bracket, 2y to this bracket, 2z to this bracket. So you will get 2xz minus 2xy minus 2yz minus minus plus 2xy plus 2yz minus 2xz.